Dear AI aspiring engineers, welcome to our channel Alex Tech Project. Today we came up with another new exciting project that is nothing but the face mask detection.
Face detector app. It has opened the window. You can see it on the screen. It is no mask. So when you are seeing at the camera, your face should be at least a 25 percentage to 50 percentage. Please don't go away from, but should not be too closer, but at least it has to be maintained a 25 percentage of this video. Now it is clearly showing there is no mask. Now let me take and see it. See, I am putting over here. So if I move it above like this, it is not. So maybe you try to move below of this one, at least at this, and you need to face to an 25 percentage to 50 percentage of the entire video or in a frame it was showing. So now let us see how this has been working in the background without further delay. Now let us jump into the session.
Now the overview. This face mask detector using the Keras and TensorFlow by using the mobile net and OpenCV. This is the mobile net. It is called it as a pre-trained model, so we are using like a transfer learning. That details we try to cover in a few minutes. Now it is used in the COVID time, but the engineering, the background, how it has been done, we are learning over here. Now you can see it will try to show the mask in the rectangle with a green color and showing it's a mask with 100% confidence, and here you can see no mask with 100% confidence with a red color rectangle box. How to download this project? You can come to installation, clone this one, enter into the face mask project and run the requirement.txt, and there is called face mask detector IPython notebook. It has been there. And if you want to directly run the app, there is called face mask detect underscore app.py. It is a Python, so you can run this command, so it automatically open the window and you need to face the camera and it will show with mask or without mask like this. So how this has been doing, and all these details we try to explore it. Now what I am doing, I am entering into the VS Code. You can see it on the screen, and I have cloned face mask project, and this is a data set. This is a face detector, and this is the face detector app. This is the Python app, and this is the Jupyter notebook, and this is a readme.md, and this is a requirement.txt. So this details it has been there, and this requirement is a TensorFlow 2.15, and the Keras is also same. The related packages we need to install before running it. Now I am opening the face mask detect app.py. You can see it on the screen. The first step, as usual, we need to load the necessary packages. What is this one? We are using the mobile net, so I am importing this one. From there I am importing the process underscore input, image to array, load model, and np, whatever the things that has been required. If we can scroll down, so this is the first function. So this is the for this proto text, you can see, and you can see res10 300 cross 300 ssd iteration. So these two things is useful for the detecting the face, and our model we try to detect, this is called mask detector model.hy. It will try to detect whether the mask is there or not. So here we are starting the stream, that is from the camera, which is source is 0. This is a video stream. While true, it's like as in a loop forever. vs.read, and we are resizing the frame to 400, and we are giving the detect and predict the mask. For this one I am giving the input of frame, face net and mask net. Face net means this model, predefined model, and mask net, and it will call to here, and it will try to give the faces, locations and prediction probabilities. So these three things it will try to return from this function. And here itself you can see this is the process input, image to array resize, and finally it is coming over here masknet.predict. This is calling our model, and based on this one it will try to give the locations and predictions if any faces it has been there from here. And based on that data, boxes and predictions we are taking from location and prediction. And if there is a mask or no mask, with mask or without mask, see here from prediction we are giving as a mask or with mask or without mask, we are going to over here. And if there is a mask it has been there, then we are giving green, or otherwise red color we are giving as a color. And the information we are putting put text and rectangle, cv2 dot put text and cv2 dot rectangle. So by using these two functions we are putting the text and drawing the rectangle over the image, over the face. And I'm show frame and wait key. If you press the Q on the keyboard it will try to exit. So now let us see how to run this one. Now I am going to the terminal, new terminal. This is a Python program only, just you need to run this command python.exe and the file name face underscore mask underscore detect underscore app.py mask. So this is the without the mask. Now I am taking one mask and I am putting like this just for demo. You have to move your face to little closer to the camera such a way that your image, a face image, should be a 25% of this frame, or at least a 50% maybe, but don't go far, because enter your face image should be at least 25%. You can see it on this screen. I am taking one more. I am covering, but don't put on over here or like this. So maybe put like this. So like this application is working. Now let us move how it has been doing in the background. In order so this is the Jupyter notebook I have opened. This is a face mask detection using Python, OpenCV, TensorFlow and deep learning. You can see it on the screen. From the pre-processing, see, you can see this TensorFlow Keras application is the MobileNet version 2. Layers I am doing as input, dense, flattened, dropout, average polling and the model. And here I am doing image data generator. You can see from the image. And MobileNet version 2, the processing input, and image to array, load image to categorical. And from sklearn I am importing this sklearn pre-processing, label, model selection, train, test split, matrix is a classification report, and matplotlib and numpy and os. Yeah, here for the demo I have included the epochs as a 10 and batch size as a 32. And if we can scroll down to here, if we can go over here, in this itself we have given the data set with mask, you can see, and you can come over here and you can see without the mask. So these two directories I am taking, and you can give the relative path also, it's fine. You need not to give the full path, you can give the relative path with mask and without mask. And category and categories, so these are the two directories under the data set. It will try to load the image, and the target size will be the 224. You can see it. And this is a process input. This you can scroll up and you can see this is MobileNet version 2 process input. After loading all this one, the label encoder, this is the category. So you can see the label category. It is, what is this category name? With mask and without mask. Now what we are doing, we are making as a one hot encoding, and then we are making as an numpy array, and then we are train test split we are doing. Even though the first set will be the with and without, it automatically shuffle the data and after this one we are doing the data augmentation with the rotation, zoom size, width shift, height shift, and shear and horizontal flip. So the real time data may become different angles. So what we are doing the data augmentation. So here is that pre-train, that is called transfer learning. So mobile net version, weights, parameters, this is ImageNet, include top is a false, and tensor input is 224 224 3. So that's where we are make it as a 224 224. So this is the base model, and adding extra layer to the base model. After this one we are giving as in pole size as a 7,7. This is a head model. Head model is the base model, output is the input. Then we are doing the flattening, then dense layer, then dropout, then we are making as a dense as a 2, activation as a softmax, and entire we are constructing the final model. The base input is the base model dot input, output will be the head model. So we are combining both of them, and in the base model we are not able to train, so we are making as a trainable as a false. You can see it on the screen. Then we are entering into the model compile and fit. You can see model.compile. Loss is binary cross entropy, optimizer is Adam, matrix as accuracy. Then I am entering into the model.fit. First line I am adding the augmentation, next mass size, then epochs, and I am doing the validation. So in the augmentation flow itself I have given as a train X and train Y. So you can see it on the screen. So it is running for 10 epochs, and finally I am predicting the values, and I have printing the classification report with the labels. So the entire accuracy is 98, and I am saving the model in two formats. One is H5, another one is a Keras. Okay, if I want to print the versions of all this one, what packages I have used their version, so I am printing like this. This is, it has been helpful to create the requirement.txt. So like this I am creating and saving the model. Now you can run, go to the cells and make run all, so that it can run. But what you need to do, you need to make this as a path as a fine, otherwise it will throw the error because it doesn't know this thing. So for this one what I am doing is I am adjusting this one. So now let me go, otherwise we can come over here and remove this one because already data set is there. So then we can, it is taking the average path, so it is loading the image. So here sometime it will try to take some time to processing the images. After this one it will come over here. Now one hand encoding, this one, next one is train test split, next one is a data augmentation, next one is a base model. Here it is downloading the weights. Next one will be the adding the extra layers, base model, non-trainable, so I am making as a false. Next one is compile and fit, and next one I am doing this. So here it will try to take some time to run 10 epochs. So you can see epoch 1 is completed. So epoch 1 is running. It will take some 5 to 10 minutes to train on the given data set, that is with mask and without mask. And after this one I am running the predict. After that now we have come end of the project. For more interesting updates, please like, share and comment and subscribe to our channel, and we try to meet in the next video for more interesting projects. Thank you very much, and we will meet in the next session. Thank you.